Well, Algebra 2, we're in 11.4. This is the last section of this chapter. So you'll have a book homework to do tonight, then a day to sort of just get on top of things, that there's not a new lesson, and then a practice test would come after that, with a test soon to come. And then that's it. Then it's finals, just review finals and taking finals till the very end. So this is your final lesson of new material, not just for this chapter, but for 2020. So, today, the first little point today is there's a rule to help you guess. What we've been doing lately is a lot of synthetic dividing. So small synthetic dividing recap is copy all the coefficients, a 1, a 6, a 1, and a 6. We've been trying to synthetic divide to find roots of polynomials, meaning solutions that would make them 0. We know we find 1 when we get 0 here, and the way we look for those is usually by just having to try to guess one that'll work. If we have an x cubed problem and make one lucky guess, we're down to an x squared problem, and then we can factor or do the quadratic formula. What we have today is a rule to help you make these guesses. So here's a rule to help you make these guesses is, with the polynomial, ignore everything in the middle, look at the very end, and think of every number that goes into that, all the factors of 4. 1, 2, and 4 are the factors of 4, because those go into 4. Look at the beginning number, 1 and 3. The only factors of 3 are 1 and 3. Then we can build fractions by putting these as tops, these as bottoms, and just build any fraction you can build. So you could put 1 and 2 and 4 on top of a 1, which aren't even fractions. They would just stay 1, 2, and 4. You could also put 1, 2, and 4 on top of a 3. I'm going to put those in parentheses with a plus or minus in front because positive or negative, these numbers could be the ones that work. With the next to the fourth problem, probably 4 of them will work. We have 1, 2, 3, 4, 5, 6, 12 to choose from. Positive, these 6, negative, those 6. Out of those 12, 4 of them should be hits. Without knowing that rule, you might guess a lot of numbers that are a waste of time. You might try to guess, 3s and 5s and negative 3s, or just different things that would have no hope in the world. This gives us numbers that maybe have a chance. They won't all work. Again, we have a list of 12. Only 4 of them might work because it was an x to the 4th problem. But we at least have some kind of a guideline to help us. If I did those same, let me do a small change of pace on this one. Let me go 4 here and 6 there. This will have a little bit bigger list because 1, 2, 3, and 6 all go into 6. 1, 2, and 4 all go into 4. These are going to tell us tops. So 1, 2, 3, and 6 could all go on top of a 1. 1, 2, 3, and 6 could also go on top of a 2. So 1 over 2. I will not put 2 over 2, because 2 over 2, I already have 1, and 2 over 2 is 1. I would put 3 over 2. I would not put 6 over 2, because 6 over 2 is 3. I already have that. No sense in writing that again. But 1, 2, 3, and 6, if I try to put them over 2, I get some doubles. I don't want to write my doubles. 1, 2, 3, and 6, I can also put over 4. 1 over 4 is new. 2 over 4 is not new. I already have that. 3 over 4 is new. 6 over 4 is not new. I already have that. So 1, 2, 3, 4, 5, 6, 7, 8 positive and negative versions. There'd be 16 worth trying. 4 of them would work. Odds aren't as good on that one anymore, but at least it's something. It's some sort of a guideline. Something like 4 has no hope. There would be no reason to guess the 4. When you go to do the homework on this, we can do a little bit of it now. 485 is our page. The first four, they just want you to list what is possible to guess. They don't want you to make any guesses. They don't want to see if they work, any of that. You just make a list like this of what might be worth guessing. Starting on 5, they ask you to find all the roots. And I would use this guessing game to help you along. So, look at the beginning here. We only have a 1. That's nice. At the end, 1, 2, 3, and 6 all go into 6. So the positive and negative versions, there'd be 8 possible things that might be worth a guess. 1, 2, 3, 6, and the negative versions of those. Previous day I gave you a good suggestion is if all the numbers in your list are positives, it's only worth trying negatives. So I can already scratch off those. So let's try some numbers. Try -1. Drop the 1, times that, add down, times that, add down, times that. I didn't get 0, so that did not work. So scratch that, scratch these. On your homework, it might not be a bad idea for you to write what I'm showing in pen, do the rest of it in pencil, and when something fails, you just erase it and don't have to rewrite the thing that's already up there. -1's out. -2 could be a try, so we draw, times -2, add, times -2, add, times -2, 20, no, start again. Erase this, erase these, try -3. Multiply by -3, add, multiply, add, that's not going to get me 0, so that's a waste. So it's either -6 or it's nothing. Some of the answers in the homework will be nothing. Sometimes nothing works. And if you didn't have the rule to know what guesses are even in play, you would never know when it was time to give up. But if -6 doesn't work, we're giving up. So do or die, this is it. Drop, multiply, add, multiply, add, multiply, and we hit it. -6 is a winner. We reduced ourselves from x cubed to x squared. If we could factor, we would, but we can't. If this were x squared minus 1, we could do it as a difference of squares, but this will not factor. If you can't factor, you have 2 choices, either do quadratic or sometimes a shortcut is available. For this, a shortcut is available. We're always considering things are equaling 0. So if I want to get the x squared alone, I can subtract a 1. To do the opposite of squaring, I can root. If we root -1, that is an I, which means -I is also an answer. I have 3 answers for an x cubed problem. I'm good. If you didn't understand that shortcut, you could have done the quadratic formula. A is 1, B is 0, C is 1. Here's the quadratic formula for you again. Just plug those numbers in there. It would have led you to the same 2 answers. For this problem, I have the same stuff going on. 1, 2, 3, 6. -1, -2, -3, -6. Because I have the same numbers at the end as before. I had a 1 at the beginning as before. So I'm going to need to make a guess. 1. I need to remember to put a 0 for the x cubed that wasn't there. 1, 2, 6, stop, synthetic divide. Again, only positive numbers here. So positives have no shot. We need to only try negative numbers to maybe work. If people were here, I would have somebody pick a number, any number, because it's just sort of random guessing. I have a sheet of notes though, so maybe I'll do a little sheet here. So we could go negative 1 will synthetic divide. Negative 1 did not work. So we could try negative 2. Synthetic dividing with negative 2. That's not going to get me 0 either. So I'll try negative 3. There's no way that's going to be 0. So it's negative 6, do or die. If negative 6 works, we're going to keep working this problem. If negative 6 doesn't work, we're just out. And that's going to be like in the 200s. This is in the 200s. There's no way that's going to happen. So sometimes there is no answer. And that's why this initial fact about what numbers are worth guessing is a really good fact. Because if we didn't know that, we wouldn't know that we might be able to just quit. Last one of the day. 1 and 2 go into that. 1 and 3 go into this. So if I put 1 and 3 on top of 1, that's possible. If I put 1 and 3 on top of 2, those are possible. The negative versions of themselves are also possible. So out of these 8, I'm hoping that 4 of them will work. I'll just have to guess one of them to start. 2, negative 7, negative 35, 13, 3, no zeros because I didn't skip anything. Oh, what do I want to try? I'll try. No, 1's not going to work because I gave you a trick for 1. If you add these up, if you add these numbers up and it makes 0, that gives 1 an opportunity. 1 does not have an opportunity here. I'm feeling maybe a negative 3. Taking a peek at my notes paper, negative 3 is going to be a win. I felt like I wanted to pick something bigger because like 35 is a decent size number, so I felt like one of the 3s might be the way to go. Drop 2, times that, add down, multiply there, add down, multiply by the box, always adding down and then multiply by what's in the box, and I got a 0. And now I'm going to guess again. Since this was x4, I'm down now to x3. It's worth making a new list for ourselves. Okay, now we just lost our 3. The only things that go into this are 1s. So anything that involved our 3s, those just went by the wayside. And we're looking at either halves or negative 1s or negative halves, something in that family. You could just guess any of them, either a half or a negative 1 or a negative half. Most people would probably try to avoid the fraction at first. So 2 times that, add down, times that, add down. That's not going to get us a 0 if we keep going. So negative 1 is out. We're going to have to work one of those fractions. Given their choices, I would think most people would try the positive fraction first. So 2 times a half is 1. Adding down, times a half. Adding down, times a half. Adding down. There's another hit for us. This is now an x squared problem with an x and a number. Factor if you can. And then that won't factor more. So we would look to do the quadratic formula. A is 1, B negative 6, C is the other number. So 6 plus minus root B squared minus 4 times A times C, we get a minus minus making plus. Because if we multiply these by 4s, we get a 4, but minus minus is a plus. All on top of 2A is a 2. So 6 plus minus root 40 over 2, if I add those together. 6 plus minus 2 root 10 over 2, because we need to think back to our perfect squares. 4 goes into that 10 times. The root of 4 is a 2. The root 10 is just sort of stuck. Best answer there would be 3 plus minus root 10, because we can divide the 2 into both of those. So our answer, here's 2 answers, because the plus or minus, plus that, that's our 4 answers. The last group of homework is still doing that, but the directions say to find only the rational roots. So 5 to 16, we have an approach there to try to find all the answers, which means quadratic formula and i's and things if necessary. Finding only rational roots means don't worry about i's, don't worry about square rooty things, don't worry about the quadratic formula. So if I retooled this to say find only the rational roots, if it were in that section of homework, we would have found this and we would have found this. We would have looked at this, and as soon as we realized that the quadratic formula needed to happen, we'd have failed. We'd have just had those 2 answers and quit. This problem would have been no different. So we quit. This problem, we would have gotten to here and realized we were going to get not able to factor, and we had quit. So on 5 to 16, even if you have to do quadratic formula or something, you keep doing it. But on 17 to 24, find only the rational roots means if you get to a point that you can't factor the x squared problem, just give up and get out of there. So 484, 485, that's the homework. Email me if you have questions.